Greetings, research students. My name is Bob Gottwals. I teach in both the NCSSM residential program and one of the research programs in that program. I also teach in the online program. I'm going to talk to you very briefly about getting started with your research and specifically about finding information in the journals. So what you see in front of you is a picture of what I call the research funnel. You're starting at the top here with some general topic or idea of interest area, and that goes into your funnel. And then the next step is on the right-hand side. We do a general review of the literature. You start reading textbooks, encyclopedias, online sources such as Wikipedia, etc. Get some basic background, basic information. Move from there to an introductory level, reading the journal articles, what's known as the primary literature. You become increasingly specific in terms of looking for journal articles, and as you get to know more, eventually you hopefully get to the point where you can have some personal communications, if possible, with the researchers in the field. So as a quick example, a couple years ago, I was invited to work at Appalachian State in a National Science Foundation program. And I had recently read an article in what's known as the Chemical and Engineering News. So here's an excerpt of that, where they were talking about the desire to figure out why we're losing all these honeybees. And it turns out that we're losing them because of some of the pesticides we're using. So in reading this article, I got interested in, do we actually understand how pesticides are influencing the destruction of honeybees? So I went from there and read an article in Nature magazine. Again, this is designed sort of be, it's for scientists, but it's also an article sort of a general nature. You see that it's pretty short. Excuse me. It's only about 1 page long, but they talk about some of the reasons for honeybee issues. I went from there to actually in Time magazine, about the same time, there was an article about what it's like to have a world without bees. So there was a really good article on why we're losing honeybees, so I read that. And again, I moved to now more very specific journal articles. This one is the pesticides are called neonicotinoids. So in the honeybee, which is known as Apis melliflora. So this was an article that was very detailed in terms of what we know about how honeybees are being affected by these particular pesticides. And based on that, I wrote an article with a colleague from out in Statesville, North Carolina, called Docking Studies of Neonicotinoids in Apis melliflora. So starting with that general purpose article that I read and got interested in what's happening with bees, and working through the journal articles, including things like Time magazine and Nature magazine, was able to write a 6-page paper looking at how these insecticides influence bees. I currently have a student in my research program who is interested in looking at how electrons go through diodes and are the basis for light-emitting diodes or LEDs. She's specifically interested in organic light-emitting diodes, and this is the proposal she submitted for her research work. And what we figured out is that we don't know anything about how to study electron motion in different materials. Specifically, what we're looking for is charge distribution. So we went to Google Scholar, and you can see I've already done a search here. I put this in quotes so the words charge and distribution are together. Okay, I'm going to do a search on Google Scholar, and I got about 1.1 million results. That's a lot of things to go through. Okay, so what I'm going to do now is just start looking through some of these articles. I read the titles, Okay, a new approach to solutes. Well, we're not in a solution, so that's not a good article. Okay, I'm not really looking at bipolar charge distribution. Okay, I'm not looking at, well, that might be a potential article. I'm not looking at quantum shots, so I keep scrolling down through here. I'm looking for titles that might have something that is of interest here. Okay, not finding anything particularly useful. Okay, so given that what we want to do, okay, is we want to know what are the methods of computing charge distribution. I'm going to add methods as a keyword here, and notice I come up with some of the same articles. Okay, but oh, here we go. Charge distribution in a water molecule, comparison of methods. That looks like a really potentially good article, because what I'm interested in is what are methods that are used to try to calculate charges in molecules. And I know, because I'm a chemist, that water is a pretty simple molecule. So if I can understand how to calculate charges in a water molecule, I might be able to figure out how to calculate charge distribution in a more complicated article. So I'm going to click on that one there. And what are some things that I'm looking for here? Again, I'm still at the point of just wanting to see what this article might have. Okay. What I noticed, by the way, while this is loading, is what journal it's in. It's in the Journal of Computational Chemistry. Okay, that's a good thing to know, because we are doing computational chemistry, and that's the right journal article for this. It's a relatively recent article, 2005, so not too old. And I'm looking at the, let's see if I scroll down here, it gives me an abstract here, so it's talking about charge distribution. Yes, that's what I'm interested in. It's talking about quantum mechanical methods. Yes, that's what I'm interested in. And it gives me an abstract here that says they use 4 different methods, and here they describe the methods, and I know what those are. And combine that with 6 different what they call population analysis, and I care about that because I care about what is the population of electrons in these structures. And so this looks like a really good article. So to save time, I already went and got that article, so here it is. Again, it's in the Journal of Computational Chemistry. There's my title. I don't know these guys, Martin and Zipse. Okay. One of the things that I do is I look at who the authors are, because I want to know, are these people that I know? Do I know these people? Do I know their work? Are these people that I trust? And there's my abstract from before. They're saying they're going to use 4 different quantum mechanical methods and 6 different population analysis methods. That's good news for me and for the research student, because those are the kinds of things we want to calculate. Again, there's my keywords if I need to do some more searching on that. Okay, there's the introduction. I don't ever read that, at least not until later. Okay, I don't read the computational methods. There's the results and discussion. I'm going to scroll sort of past all the tables and data sets, lots of data in here. Okay, what I'm going to do is I'm going to scroll all the way down to where the conclusions are, okay? Because I want to see what did they learn. I have a pretty good idea of what their research question is. If I go back up here for a minute, okay, the research question is, what methods are used to calculate charge distribution in the water molecule? So I can take the title of this paper and I can basically turn it into a question, and that becomes the research question, okay? And I'm going to go down here now to the conclusion. And they did this really very well. It turns out, if I look at the conclusions, they say there are 7 different things that they learned in this particular study. Okay? They said they learned that, okay, this particular method of doing analysis does this. Okay? We got a little bit slightly different results when we did that. Here's what we got when we used these methods here. Here's what we got when we used those methods here. At the end of the day, they say, Here might be the best method. So I'm really looking at these, the conclusion there, to learn what the answer was to their research question. And they do a nice sort of take-home message at the end that says, based on everything we're doing here, this particular methods with this particular type of calculation provides the best method. They are telling me I need to be careful about trying to apply these conclusions to other systems or larger systems, okay? But they're basically telling me that here's a good place to start. I also spend a fair amount of time looking at the references. I'm looking to see who is cited here. Are these people I know? Do I see the same couple people cited a number of times? I might. So, for example, I see Lee, Yang, and Parr. They pop up in a couple places. I see this name Henry pop up a couple places. Okay, so I look for those things because I do want to know who's doing this work. Okay, now that I've read the conclusion, probably what I'm going to do is I'm going to go back and I'm going to start looking at some of these graphics and data tables. Okay, so I look at this data table, and what they're telling me here in the article, they said a good answer for charge distribution in water should be about minus 0.6. So I got that somewhere up above in the article. So I look at this method here. All of these, if I look at 0.6 as the right answer, all of these methods here are sort of all over the place. For NPA, this method here, I got some stuff, good answers at here and some here. Okay, for AIM, I got this answer, and again, 0.6 is my answer. But now coming down to these methods, look at all these things that are, some of these methods that are right at minus 0.6. So I look at the graphics as my next thing to see, okay, what will these pictures tell me? I look at the captions and see what those have to say. Okay, now I might go look at the data. I try to work my way through the data. I read the caption here, try to figure out what their units are, and start walking through this data to try to figure out, again, I'm looking for something around a minus 0.6. Okay, I'm getting stuff there, minus 0.5, minus 0.56. Okay, so those might be some pretty good methods there. At this point, what I would probably do is I would then probably go, because we're interested in trying to do this stuff on our own, is now I would look at the computational method section, okay? I would go down and I would see all calculations were done using a particular piece of software called Gaussian 03. That's good news because we have that software at the School of Science and Math, okay? I would go and read through here and try to figure out exactly how they did their study. And what I might do is, depending on how much time I have, is I actually might try to replicate their results. I might try to use their methods here as described in their computational methods, go build water myself and try to run their calculations and see if I'm able to get the same values that they got for their results. And mostly what I'm trying to do by doing that is teach myself how to calculate charge distribution, in this case in the water molecule. Okay, the results and discussion, I would sort of skim through that, but again, what I'm really looking for in that part are the charts and the data tables. Those are the things that I really look at. The last section here that I sort of flew by is the introduction section. I will sometimes skim through that because I'm an experienced computational chemist. I probably know a lot of what they're describing in the introduction. For you as a beginning researcher, you probably are going to want to go ahead and read that introduction. The one part that I do read in the introduction is I typically read the last couple sentences, because if they're good writers, if they know how to write articles for the literature, the very last sentence in the introductory section is going to be their research question. And they do a pretty good job there. They say, our interest here is in the comparison of different methods to describe the electron distribution of water as broadly as possible and assess the sensitivity of these calculated charges to changes in these various different methods. So they're doing a very good job in that very last sentence of their introduction of saying, this is what we're going to do, and this is why we're going to do it. Okay? I might skim through again the introduction. You remember I mentioned that they determined the right answer was minus 0.6 or minus 0.66. I wouldn't have known that if I hadn't sort of done a skim through the introduction to know that that's their target. But that's how I go. So again, to recap, okay, I found this article because we were looking for an article that would teach us how to calculate charge distribution in the case of the student in an organic LED. We found the one on the water molecule. It taught us a lot about how to do that, what calculations to run, what software to use. By reading the article, looking at the abstract, skipping back to the conclusions part of the article, we learned what they found to be the best way to do charge distribution, at least in a water molecule. Okay, we looked at all their tables and charts to really get a sense of, and you can see really clearly if our target is minus 0.6, you can see almost at a glance which things worked well and which things didn't work well. And based on that, we now went back to the computational methods section. We read about how they did their things. And again, we verified what they were doing by going back and reading the introduction. So that's a very short overview on how to find materials. Again, we use Google Scholar. There's lots of other things you could use here. You could use Science Direct. There's a multitude of resources that you can use to find these articles. A lot of times you might need to ask a research librarian to help you actually get the article because it might not be available to you because you don't have a subscription to that particular journal. But that's the process that we use at School of Science and Math with our research students to help them sort of get things narrowed down. I hope this helps, and we'll see you online.